And in this video, we're going to wrap up 8.1, the law of sines. This is day 3, and we're going to find the areas of oblique triangles using this law of sines. The procedure used to prove the law of sines leads to a simple formula for the area of an oblique triangle. If we look at the figure below, note that each triangle has a height h equal to b times the sine of a. Consequently, the area of each triangle is, we know this formula from years and years of math, half base times height. Well, half, the base is c, and the height is b times the sine of a, or 1/2 bc times the sine of a. And by similar arguments, we can come up with the other formulas. The area is 1/2 ab sine c, or 1/2 AC sine B. If we look at all these, we do notice a pattern. There's an A, B, C in all of them. There's a 1/2 to begin each of them. And then we're multiplying two sides. In the first one, it's BC, and then it's AB, or it's AC. And then we have the sine of an angle. The angle is the one that's not one of the two sides. Here the sides were B and C. This is the sine of angle A, the one that's not over here. In the next one we have AB and the sine of C. A and B are the sides. C is the angle that we're taking the sine of. Or you could do 1/2 AC sine B. Whichever one of those fits the problem at hand. And note, if angle A is a 90-degree angle, the formula gives the area of a right triangle. Remember, from the unit circle, the sine of 90 degrees is equal to 1. So here, the sine of 90, this would equal 1. And we would just have 1/2 BC. And if it's a right triangle, the B and C are the base and the height. Neat. So here in example 6, we're going to find the area of a triangular lot. Find the area of a triangular lot that have two sides of length 90 meters and 52 meters, and the included angle of 102. So the sides we have are A and B, the angle we have is C, so we're going to say the area is equal to 1/2 the sides that we have, 52 times 90 times the sine of the included angle, 102 degrees. And then that's just pushing buttons on the calculator. The 1/2 you can put in as a 0.5. 0.5 times 52 times 90 times 102 sine. Hit the equal key, and you get approximately 2289. 2,289 meters squared. Yeah, we did have meters, and we're talking area, so it's meters squared. Easy enough. Example 7 is a little trickier, though. An application of the law of sines. The course for a boat race starts at point A, right here. Starts at point A, proceeds in the direction south 52 west. So we're on the south line, and we veer 52 degrees to the west. So we're headed in this direction to point B. We hit point B. And then we take off in the direction of south 40 east. So here's our south line, and we deviate 40 degrees to the easterly direction, and now we're on this line. And we continue to point C. Once we're at point C, we turn right back to A, and we head back to where we started. We're also told point C lies 8 kilometers directly south of A. So here's point A, directly south is point C, and this is 8 kilometers. Approximate the total distance of the race. So what are they asking us to find? The total distance of the race. We're starting at A, we go to B, we change course, we come down to C, we change course, we head back to A. What do they want us to find? They want us to find the perimeter of the triangle. How do we find the perimeter? We add up all the sides. So what we want to find is side A plus side B plus side C. And they did give us side B here. Side B is 8. So what we're trying to do here is find sides A and C. So we want to solve for this A and we want to solve for this C. But they kind of gave us some odd information. We don't have exactly everything we need. We have A, angle A, and we're looking for side A. And let's see, what else did they give us? Nothing in the triangle. But if we look at the diagram, out here we have a 40-degree angle. How the heck is that going to help us? Well, let's see. Looks like we have, this line is on the north-south line. They told us that in the setup, and that's 8 kilometers. If we go, here's our north-south line from our turn at point B. At point B, we turned south 40 east. So this is a north-south line, and we turned 40 east. Does that help us? Well, both lines I highlighted in red are north-south lines, so they are parallel. And here I'll highlight it in green is a transversal of parallel lines. What do we know about parallel lines crossed by transversals? They have some angles that are congruent. Here we have alternate interior angles. Our transversal cuts the parallel lines. Interior to the parallel lines and opposite sides of the transversal, alternate interior. We can deduce that this angle is also 40 degrees. So now we know angle C. We want side C across from it. We have angle A, and we want the side across from that. Well, now in the triangle, in our triangle ABC, we now have two angles, 52 and 40. So if we do a little scratch work, we find out that angle B is 88 degrees. Now this picture is getting a little cluttered. Let's do our own. Here's a triangle. We know this is 8. We know this angle is 88 degrees. We have a 52-degree angle up here, 40-degree down here at C, and we know side B is 8. So we have one side, we have all three angles, and we're missing two sides, C and A. So we now have everything we need to solve this problem. We want to find sides A and C and then add all three sides up. Oops. So, I didn't want to grab everything, but I guess I can just do this. And we can get that out of the way. Let's set up the whole law of sines. Why not? A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. And we know all the angles. A is 52 degrees. B is 88 degrees. And C is 40 degrees. Those are our denominators. And that's a 40. And the only side we know is side B. And that's 8. So we want to find A, we want to find C. Here's the first one I want to look at. We want to cross multiply and solve for side A. So when we set this up, we're going to have A is equal to 8 times the sine of 52 divided by the sine of 88. And we punch that into the calculator, and we get A is approximately 6.3. And I think we were in miles here, weren't we? 8 kilometers. We're in clicks. So this is 6.3 kilometers. So now we have to find, well, I'm going to come up here. I know that B is equal to 8. They gave us that. We just found A is equal to about 6.3. And these are clicks, kilometers. Now we're going to find the last side C. So we're going to concentrate on this part of the proportion right here. Cross multiply to find C. C is going to be equal to 8 times the sine of 40 divided by the sine of 88 degrees. And we punch that into the calculator, and C comes out to be approximately 5.15 kilometers. So C is 5.15 kms. They were asking us to find the total distance of the boat race, or the perimeter of the triangle. Well, we find the perimeter by adding A, B, and C. And when we add those all up, we get about 19.45 clicks. There we go. For the huddle, in the first one, nice easy one, find the area of the triangle. We have side A and side B, and we know the measure of angle C in degrees. So we can use the formula, set that up, find the area, quite simple. In number 49, bridge design. Bridge is to be built across a small lake from a gazebo to a dock. See the figure. The bearing from the gazebo to the dock is south 41 west. So here's the gazebo. The dock is over this way. Its bearing is south 41 degrees to the west. So here's a 41 degree angle from this north-south line. From a tree 100 meters from the gazebo, here's a tree 100 meters away from the gazebo. The bearing to the gazebo and the dock are south 47 east and south 28 east, respectively. So here's our tree. Our bearing is south 28 east to the dock here, or south 74 east to the gazebo. We want to find the distance from the gazebo to the dock. So what we want to find is the distance from the gazebo to the dock. We're trying to find this bridge. And you can, redraw this up, label it ABC however you want, but we want this length. This is a tricky one. The key here is to look for parallel lines crossed by a transversal. That might help a little bit. So pause the video, try those out, and see if you get the right answers. Okay, first the easy one. Here's 39. We want to find the area of the triangle with those given conditions. So this one, it looks like we're going to have area is equal to 1/2 the two sides we have, A times B, 4 times 6, times the sine of the angle, the sine of 120 degrees. And when I'd punch this in my calculator, I'd sort of do it in reverse. 120, hit the sine key, there's your decimal. Times 6, times 4, times 0.5. And you're going to get the area is approximately 10.4, and they did not give us any kind of units, but it would be whatever units squared. Feet squared, meters squared, miles squared. So that was an easy one. The bridge problem is a little more involved. And I want to take the picture they gave us and redraw it without maybe so much of the clutter on it. And let's see, that's good enough. I'm going to do, we have our bearing lines, those north-south lines. I'm going to do those in red and make them dotted. The hint I gave was to look for the parallel lines. And there, the red dotted lines are the parallel lines. I'll use blue for the angles. We were given that this was 41 degrees. Now over here, we have this smaller angle was given as 28, the bearing from the tree to the dock, and then the bearing from the tree to the gazebo, this bigger angle was 74. Now remember that 74 is not just within the triangle, that is this entire blue angle. Now, how does that help us? Well, one thing we can do is find this angle here within the triangle, and I'll use green for that. This angle, the green angle, is going to be 74 minus 28, and that turns out to be a 46 degree angle. 46 degree. Now what we need to find is this angle here inside the triangle. This one I'll do here in green. How can we do this? Well, let's see. We have parallel lines. The red dotted lines are parallel lines, and here is a transversal. We're cutting across it. So if we have parallel lines cut by a transversal, what do we know about the same side interior? These angles in here, they're not congruent, but if we remember our geometry, they add up to 180 degrees. So we can figure out this missing piece inside. These are going to add up to 180. And we know from our given information, this one was 74. So 180 minus 74 is 106. 106 degrees. And if we've already used up 41 degrees here, 106 minus 41 leaves us 65 degrees. This inside angle here, just in the triangle, is 65 degrees. We almost got everything we need. Oops. So we got a 65 degree angle in the triangle. We have a 46 degree angle in the triangle here. If we subtract those from 180, we find out that this is a 69 degree angle. Now we were trying to find, we're getting a little cluttered in the picture here. We were trying to find this side, and I'll highlight it in green. This is the side that we wanted. Ooh, and I did miss, we do have one side that we're missing here. The distance from the tree to the gazebo is 100 meters. From a tree 100 meters from the gazebo. So this side is 100. So there is the angle on the side across from it that we know. This is definitely going to be part of our proportion. 100 over the sine of 69 is equal to, we want to find the length of this dock that I highlighted in green here, and we do know the angle across from that is 46 degrees. So let's call our dock length x. X is our length that we're looking for over the sine of 46 degrees. And we can set up our proportion, cross multiply, and we're going to get x is equal to 100 times the sine of 46, all divided by the sine of 69. And if we punch that into our calculator, we're going to get x is approximately 77 meters. 77 meter long dock, from the dock to the gazebo. That was a good one. The assignment, 8-1 day 3, page 604 and 5, number 30 to 34. You're going to want to convert any degrees and minutes and seconds into decimals. Remember, on the calculators we're using, that is, I believe, straight down bottom left corner. Maybe it was a straight bottom right. The button was DMS to decimal degrees. Degrees and minutes and seconds to decimal degrees, or decimal degrees to DMS. We want to convert from degrees and minutes and seconds to decimal degrees. Remember, punch it into your calculator. Punch in your degrees, the whole numbers, and then your decimal point, and then punch in the minutes and seconds, like 23 minutes, 46 seconds, and then hit the convert to get that as a decimal. For number 42, that's a lot like the dock gazebo problem. Look for parallel lines, and remember your properties of parallel lines. Some angles are congruent, some angles are supplements. Enjoy.